You ready? 1, 2, 3, smile.
So good morning everyone. Madungog ako guys.
Morning.
So before start, let's pray. So in the name of the Father, the Son, and the Holy Spirit, amen. So thank you, Lord God, for giving us another day. Thank you for the blessings and protection. Give us knowledge and wisdom as we are about to learn. We praise and glorify you. This we ask in the mighty name of Jesus. Amen. In the name of the Father, the Son, and the Holy Spirit. So we are going to talk all about the electricity, electric charges, and electric fields and electrostatics. Next slide, please. So we are the virtual of GSIE Rasmus. So by the way, I'm Lynn Joanakis, and my group mates are Amahan Maria Erica, Montalvo Joseph, and Bustillo John Boy. Next slide, please. So first, electricity. So electricity is a form of energy that is created from the movement of electrons of atoms when the electrons move from one atom to the next. Energy is created. The word electricity comes from the same root word as electron. Electricity is a general term for anything that involves an electrical charges. Next slide, please. So the science of electricity. In order to understand how electric charge moves from one atom to another, we need to know something about atoms. Everything in the universe is made up of atoms. Every star, every tree, every animal, the human body is made of atoms. Air and water are too. Atoms are the building blocks of the universe. Atoms are so small that millions of them will fit on the head of a pin. Atoms are made up of even smaller particles. The center of an atom is called the nucleus. It is made of particles called protons and neutrons. The protons and neutrons are very small, but electrons are much smaller. Electrons spin around the nucleus and shells a great distance from the nucleus. If the nucleus were the size of a tennis ball, the atom would be the size of the Empire State Building. Atoms are mostly empty space. If you could see an atom, it would look like a tiny center of ball surrounded by giant invisible bubbles or shells. The electrons would be on the surface of the bubble, constantly spinning and moving to stay as far from each other as possible.
Excuse me, class. May I know who's presenting now?
Leave me.
Joanna Kathleen?
Yes, miss.
Okay.
Next slide, please. So the electrons in the shell closest to the nucleus have a strong force of attraction to the protons. Sometimes the electrons in the outmost shell do not. These electrons can be pushed out of their orbits. Applying the force can make them move from one atom to another. These moving electrons are electricity. So electricity is the flow of electrical power or charge. It is a secondary energy source, which means that we get it from the conversion of other sources of energy like coal, natural gas, oil, nuclear power, and other natural sources, which are called primary source. The energy source we get to make electricity can be renewable or non-renewable, but electricity itself is neither renewable or non-renewable. So electricity is a basic part of nature and it is one of the most widely used forms of energy. Many cities and towns were built alongside waterfalls, a primary source of mechanical energy that turns water wheels to perform work. Before electricity generation began over 100 years ago, houses were lit with kerosene lamps, food was cold in ice boxes, and rooms were warmed by wood burning or coal burning stoves. The source of power for many of our home appliances, tools, and machines, most of the world's electricity is produced by large machines called generators and sent to our homes through electrical wires. Next slide, please. So beginning with Benjamin Franklin's experiments with a kite. One stormy night in Philadelphia, the principle of electricity gradually became understood. Franklin's experiments demonstrate the connection between lightning and electricity. The kite experiment is a scientific experiment in which a kite with a pointed conductive bar attached to its apex is flown near thunder clouds to collect electricity from the air and conduct it down, it down the wet kite string to the ground. It was proposed and many have been conducted by Benjamin Franklin. With the assistance of his son William Franklin, the experiment's purpose was to uncover the unknown facts about the nature of lightning and electricity, and with further experiments on the ground to demonstrate that lightning and electricity were the result of the same phenomenon. Next slide, please. Thomas Edison helped change everyone's life. He perfected his invention the electric light bulb. Prior to 1879, direct current electricity had been used in arc lights for outdoor lighting. In the late 1800s, Thomas Edison used this carbon filament bulb in the first public demonstrations of his most famous invention, the light bulb, the first practical electric incandescent lamp. The electric bulb creates light when electrical current passes through the metal filament bar, heating it to a high temperature until it glows. Despite its great importance in our daily life, most of us rarely stop to think what life would be like without electricity. Yet, like air and water, we tend to take electricity for granted. Every day, we use electricity to do many jobs for us, from lighting and heating, cooling our homes, to powering our televisions and computers. Electricity is controllable and convenient from energy used in the application of heat, light, and power. So, ang electricity gamit dito sa pinagbuhat. So, the law of conservation of energy states that energy can be neither be created nor be destroyed. Rather, it can only be transferred from one form to another. So it means na we don't actually create it. We start with energy that already exists in natural gas, coal, wind, and other sources of electricity. So na-exist na siya daan. And then use our generating process to transform it into electric energy that we use in our homes. We transfer the energy from our raw resources into something more useful. However, even though energy can't be destroyed or lost, it can be wasted in the transfer from one side to another. So, like sa unang wala pa ang LED light, ang gigamit sa unang nga bulb kay like incandescent light nga kusog kay musigan yung transformed into electrical energy into light energy and heat energy. So kusog siya mo pagawas og kanang electron, so makasi ang kanang electricity. So karon nga invention na ang mga LED lights mo ng light emitting light, gamay ra siya makuha o kanang much greater efficient. So next slide please. So electricity, it has two types, static and current or dynamic. Under the current or dynamic, nasa siya two types, which direct current or alternating current. So first, static electricity. Next slide, please. So, ang static electricity, a build-up of electrons, while ang current or dynamic electricity, kay mo ang the flow of electrons. Ang static electricity stays in one place until it jumps to another object, while ang current electricity travels through a conductor, a substance that allows electrons to move easily through a wire. Static electricity has limited use to power modern technology. So, limited lang siya niya, while ang dynamic can be easily harnessed to do work and power modern technology. So, under the static electricity, electric charge are at rest, while the current electricity, electric charge are in motion. So, static electricity happens sporadically and usually uncontrolled. So, kanang makalit-kalit ka, dili sa siya makontrol ng kind of electricity. While ang current electricity normally is controlled and is used in a wide range of applications. So, example of current or dynamic electricity are starting a motorbike, turning on a light, watching TV, playing video games, charging a cell phone, and many more. So, next slide, please. So, example of static electricity, When you rub your feet on a carpet and rub something when you touch it, it is static electricity that you have built on the surface of your skin discharging into another object. So, sa kaning example, you build up a positive charge because negatively charged electrons are being lost to the carpet. Carpets are often made of materials with the properties of an insulator. So, ang kaning insulator do not easily give up electrons but can get a local charge when electrons from a conductor are rubbed off on them. However, ang body kay mo na sa kanang conductor sa siya, di ra kay ang kanang mga materials, but also ang body. So, conductor or ang katong body have frozen bound valence electrons which are easily transported or lost, in this case from your body to the area of the carpet when you're shuffling. Charge imbalance is created between you and the carpet. So when you touch a metal object, so you get zapped. So these electrons immediately move to your body to restore the electrical or the charge imbalance. So another example is when a balloon is dropped on your hair, the balloon picks up extra electrons when they attract your hair to the balloon. This causes a literal hair-raising experience. So electricity has been moving in the world forever. Lightning is a form of electricity. It is electrons moving from one cloud to another or jumping from a cloud to the ground. Next slide, please. So the two types of electric current. So direct current and alternating current. Next slide. So direct current. So it's the power that comes from the batteries, fuel cells, and solar cells. Battery has a plus and minus sign in them. Plus sign stands for positive and minus stands for negative. The electric current in the batteries always flows in the same direction and it flows from the positive to the negative side. So batteries power things like game controllers, flashlights, phone, even the TV remote. So, kaya naman ito batteries ka. Nara na sa mga kuan. Gamit sa mga gadgets, even phones may batteries. So, fuel cells also work like batteries except they don't need to be recharged. Fuel cells take chemicals like hydrogen and oxygen and put them together. When the two chemicals react to each other or have a chemical reaction, electricity is created. The fuel cells can provide power for something as big as utility power stations, or something as small as laptop computers. There are even hydrogen-powered vehicles that use fuel cells. Some of these vehicles include forklifts, cars, boats, and buses. The solar cells look like a black rectangles made of glass. The material inside the boxes release electrons when the light or the sun shines on them, which then creates an electric current. Solar cells uses the light from the sun to make electricity. So watts money ang how power a light is using, voltage, how much power is available for the light to use, and amps, how fast the electrons are traveling to the light bulb. Next slide, please. A battery produces electricity using two different metals in chemical solutions. A chemical reaction between the metals and chemicals frees more electrons in one metal than in the other. One end of the battery is attached to one of the metals, the other end is attached to the other metal. The end that frees more electrons develops a positive charge and the other end develops a negative charge. If a wire is attached from one end of the battery to the other, electrons flow through the wire to imbalance the electrical charge. A load is a device that does work or performs a job. If a load such a light bulb is placed along the wire, the electricity can can do work as it flows through the wire. In the picture above, electrons flow from the negative end of the battery through the wire of the light bulb. The electricity flows through the wire of the light bulb and back to the battery. Next slide, please. So shorter, longer, thicker, and thinner wires are also affect how electricity travels. Shorter and thicker wires allows allows for better flow of electrons than thinner and longer wires. Next slide, please. Alternating current. The electric current that reverses direction many times a second. This power comes from the power plants. The electricity travels through the power lines that you see along roadways and open fields. The electrons travel in a big loop from power plant to the wires that are hooked up to your house and then back to the power plant again. So when you turn on the light in your home or plug something to an electrical outlet, the power flows from the power plant, but before it enters your home, it passes through something called transformer. Transformers are attached to the utility box or power poles near your home. The electric current flows from the transformer to the circuit breaker or fuse box in your home. That fuse box enroutes the electric current to each of your outlets and switches. The transformer's job is to make sure that the right amount of power is going to your home. This is very important job. So, kailan ba ito na transformer? Nasa poste. So, dira magpuan sa ng electricity kanang mga mag-support work ang padung sa inyo sa kabay. So, too much electric current flows all at once, it could blow a circuit and cause all the appliances in your home to stop working. If too little current in it, it wouldn't be enough to power all of your appliances. So dapat kanang sakto ra jud ang electric appliance, dili manubra o tuwang kay kung manubra man gud kay kanang mabuto siya ba niya kung gamay ra sa dili makaya o kang power all sa inyong mga appliances. So, next slide, please. So, a generator is a device that converts mechanical energy into electrical energy. The process is based on the relationship between magnetism and electricity. So, a typical generator at a power plant uses an electromagnetic, a magnet produced by electricity, not a traditional magnet. The generator has a series of insulated coils of power that forms a stationary cylinder. The cylinder surrounds a rotary electromagnetic shaft. When the electromagnetic shaft rotates, it indicates a small electric current in each section of the wire coil. Each section of the wire becomes a small separate electric conductor. The small currents of individual sections are added together to form one large current. This current is the electric power that is transmitted from the power company to the consumer. Next slide, please. So, power plants. Use different kinds of fuel to produce electricity. So, thermal power plants use coal, biomass, petroleum, or natural gas to heat water into steam. That steam then powers a generator which produces electricity. So, nuclear power plants use fission, which means splitting atoms. Splitting the atoms creates energy, which is produced heat, which also creates steam. Next slide, please. So, geothermal power plants uses the heat located inside the earth to create the steam. So, makaproduce of the energy muna mga power plants. So, hydropower plants use wind and moving water to create steam. Next slide, please. So electricity can be produced by magnets. Electricity is created when electrons move from one atom to another, like what I said before. So magnetic fields can move electrons. Power plants use giant magnets to create electricity in a generator. The generator has a coil of copper wire inside the magnet. Steam makes the generator spin, causing the electrons in the copper wire to flow through the power lines. The spinning of the electrons around the nucleus of an atom creates a tiny magnetic field. Most objects Most objects are not magnetic because the atoms are arranged so that the electrons spin in different random directions and cancel out each other. Magnets are different. The molecules in the magnets are arranged so that the electrons spin in the same direction. This arrangement of atoms creates two poles in the magnet, a north-seeking pole and a south-seeking pole. A magnet is labeled with north and south poles. This magnetic force is a magnet flows from the north pole to the south pole. This creates magnetic field around the magnet. Next slide, please. So have you ever held two magnets close to each other? They don't act like most objects. If you try to push the if you try to push the south poles together, they repel each other. So two north poles also repel each other. Turn one magnet around and the north and the south poles are attracted to each other. The magnets come together with a strong force, just like protons and electrons. Opposites attract. These special properties of magnets can be used to make electricity. Moving magnetic fields can pull and push electrons. Some metals like copper have protons that are loosely held. They can be pushed from their shells by moving magnets. Magnets and wire are used together in electric generators. Next slide, please. So the transformer moving electricity. So to solve the problem of sending electricity over long distance, William Stanley developed a device called a transformer. The transformer allows electricity to be efficiently transmitted over long distance. This made it possible to supply electricity to homes and businesses located far from the electric generating plant. The electricity produced by a generator travels along cables to a transformer, which change electricity from low voltage to high voltage. Electricity can be moved long distance more efficiently using high voltage. Transmission lines are used to carry the electricity to a substation. Substations have transformers that change the high voltage electricity into lower voltage electricity. From the substation, distribution lines carry the electricity to homes, offices, and factories, which require low voltage electricity. Next slide, please. So electricity is measured in units of power called watts. It was named to the honor James Watt, the inventor of the steam engine. 1 watt is a very small amount of power. It would require nearly 750 watts to equal 1 horsepower. A kilowatt represents 1,000 watts. A kilohour is equal to the energy of 1,000 watts working for 1 hour. The amount of electricity a power plant generates or a customer uses over a period of time is measured in kilowatts. Kilowatt-hour. Kilowatts-hour are determined by multiplying the number of kilowatts required by the number of hours of use. For example, if you use a 40 watts light bulb 5 hours a day, you have used 200 watt hours or 0.2 kilowatt hours of electrical energy. See our energy calculator section to learn more. Next slide, please. So electric charge, it will be discussed by Mr. Busui.
One, I am John Delib Silio, and I am the one who report the electric charge. So next slide. Walay volume pa. Jared.
Wait,
I-on mic lang, Mayor.
Professor Dave again. Let's discuss electric fields.
He knows a lot about the science stuff. Professor Dave explains.
We live in an age where we take electricity for granted. Just plug into the wall and you can power any device you want. But what's in there? What is electricity made of? The discovery of a variety of phenomena over several centuries eventually led to our mastery of this incredible power. So let's learn about it now. First, we noticed that there was such a thing as electric charge. The easiest demonstration of this involves rubbing a balloon on your hair and seeing how the balloon will then attract your hair by some mysterious force. Two balloons that have been rubbed on your hair will strangely push each other away. This occurs because of electric charge, which is displaced by the rubbing together of these materials. The hair becomes positively charged and the balloons become negatively charged, which is terminology developed by Benjamin Franklin. Opposite charges will attract one another, which is why your hair sticks to the balloon, and like charges repel, which is why the two balloons push each other away. This property of electric charge is carried by certain subatomic particles. The most common of these are protons, which are positively charged, and electrons, which are negatively charged. Along with neutrons, these make up all the atoms in the universe. For more about atoms, check out my general chemistry course. As it happens, electrons, which are the essence of electricity, are easily transferable, and it is the transfer of electrons, in this case from your hair to the balloon, that generates electric charge in previously neutral materials. Each electron carries with it the fundamental charge, which is 1.6 times 10 to the negative 19 coulombs. This magnitude is negative for the electron and positive for
So electric charge. Electric charge is a basic property of matter carried by some elementary particles that governs how the particles are affected by an electric or magnetic field. An electric charge is a property of an object. Charge cannot be created or destroyed, but it can be transferred between objects. Older- All ordinary matter contains both positive and negative charge. Electric charge is a property of tiny particles in atoms. So the electric charge conserves protons, electrons and neutrons. So the protons are positively charged and the electrons is negatively charged and the neutron is neutral or no charge. So next slide please. So law of charges. So like charges repel each other and unlike charge attract. So as what you've seen in the picture sa left side, that is a example of a like charges repel as what have you seen the balloon and the plastic rod. Kanang i-push away siya from another when the plastic rod comes closer to the balloons, and on the right side follow the attract, and as what we have seen in the glass rod, kanang gidala pa dool ang balon sa kuan, kanang gidala pa dool ang balon sa kanang glass rods kay ang as what you have seen in the glass rod is being closer to the balloons, and the glass rods are pulled to one another. So next. Transfer of electric charge. An electric conductor is a material in which charge can move freely. An electric insulator is a material in which charge can move also freely. So a substance that can easily transfer electricity charge is the electric conductor, which the charge can move freely, and also substance that does not transfer electric charge is the insulator, which charge cannot move freely. So charging by friction. So in two different insulating materials are rubbed, electrons get transferred from one body to another. So sa kanang picture kay example na, so in the sa kanang picture kay we have uncharged plastic rod and uncharged cloth. So when the plastic rod is rubbed with that cloth, electrons are transferred from the rod to the cloth, and as a result, the rod becomes positively charged and the cloth becomes negatively charged. So both of the rod and cloth are made of insulating material. Insulators prevent the electrons from moving and the charge remains static. So conductors on the other hand can move electrons. Next slide. So kanang charging by conduction. So charging by conduction occurs when a neutral object is placed in the contact with an already charged object. So sa kanang picture kay before balloon is close to electroscope, net charge on electroscope is zero. Has an equal number of protons and electrons, and the balloons has a larger number of electrons than protons. So in this process no kay kanang iyaning ipaduol ang balloon para maigo ang electroscope, kay once mahikapan sa balloon or matouch sa balloon ang electroscope, kanang yung uban negative charge sa balloon move pud sa electroscope, and the electroscope now also has a flood of negative charges, making the foil leaves now permanently negative charge and pushes away from another. According to the law of charges, they must have the same charge and must be electric force pushing them apart. So when the balloon touches the electroscope, nag-allow siya og electrons to transfer between sa two objects. So it means kanang that the electrons will transfer into the electrically neutral electroscope from the balloon, and that is because the electrons will be attracted to the protons near top near the top of the electroscope and repelled from one another where they are crowded together or close together in the balloon. So because there are balloon transfers, there are balloon transfers some electrons to the electroscope to balance out the negative charge of both balloon. And electroscope also end up having some excess electrons. So kanang sa both balloon niya kay ang electroscope also have excess number of electrons and ang foil repel excuse me, and foil repel one another because of the law of charges. So electrons causing a net negative charge, which is why the metal foils of the electroscope remain repelled from one another, and again because of the law of charges, like charges repel. So anang you charge an object is also called by charging by conduction. In conduction, you end up with the object being the same charge as the object that was used to charge it. The balloon was negatively charged and the electroscope also. So, sa kaning charging by induction, so charging by induction is electrons can react to the electric field of a charged object without touching the object itself. So, sa kanang nga picture kay pagpaduol niya sa kanang balon niya pod pagpaduol niya sa balon niya pod gi-touch ang kanang electroscope sa iyang kamot. So, when he bring the balloon near but not touching the electroscope, so the electrons are trying to stay away from balloon as far as they can get. So but if you give them a path to get even further away, they will take it. So do not do that by touching your finger to the electroscope. They will rush to your finger to get further away. When you pull your finger and the balloon away, but the electroscope has too few electrons, and so it will be positively charged, and the positive charge in the foil try to get away from each other and they repel each other, but this time it is because of a positive instead of a negative charge. So this charging by induction, and the result is that the electroscope has the opposite charge of the balloon, which charge it because electrons left the object. Charging by polarization. So polarization does not charge the net charge of the object, but rather has to do with how charges rearrange themselves with the object. So balloon is not held to the wall by ang kanading gisikitan sa balloon kay mo na ang wall. So balloon is not held to the wall by conductor and inductor. Wall is an insulator. So insulators do not have electrons which are free to move, and conductors do have electrons which are free to move. So ang balon nasa negative net charge and the protons in the wall are not going to move. However, the electrons can move their orbits around the nucleus. So, ang electrons in the wall are going to move away from the electrons in the balloon because according to the law of charges, the electrons in the wall will be repelled from electrons in the balloon because they have both negative charge. So that means ang proton in the wall kay magkaduol sa so electrons sa balloon, and the electrons in the wall from the electrons sa balloon. So next.
Excuse me, are reporters of Group 5 finished with their presentation?
Sorry miss ka lang lobat ang laptop miss. Wait sa miss.
So murag tulo pa to ang naka-present, right? Mao ni si Kuan, si Bustillo, no, was the last
Good
one
morning, Sir
to present.
Canilias.
Bustillo was the last one to present. Unya, si Lim, Joanna. Then,
Sir.
who
Wait lang
else?
nakadali, sir, ha? Nag-CR pa kadali si Sir Breakfast.
Okay, excuse me. Are you listening, presenters?
Yes, ma'am.
Excuse me, Miss. Duha pa yung
Ha? Pila ka buok duha? Si Bustillo ug si Lim, right?
Yes, Miss.
Hello?
Yes, miss.
Yes, Miss.
Then, wala nilain sa presenters sa group 5.
Apay continuation, Miss, pero nalupat pa kasi ang laptop ni Jared.
So,
Good morning, ma'am.
muhuat pa ka, yes? Ato ba to, no?
Yes, Miss.
Okay. So, ayaw lang kay ipadugay, no, para kay naparabay lain next group of presenters. Okay, thank you. So, naminaw lang ko ha while attending to our meeting. Okay, thank you.
Wait, nag-rejoin ako. Okay, paano continue?
good morning. Sorry no, nawala si Jandel kay mod sa internet connection. Hello, this is Joseph F. Montalvo speaking, and I'll be discussing one of the important concept in electricity, which is electric fields. So in order to understand it, we have attached a video in a PowerPoint. So look it up after this discussion lang since we are running of time. But let me summarize the basic idea na gi-present ato ni. So an electric field in its simplest definition is a space. It is the let me touch. It's a region of space where an electric charge experiences a force, and in this particular field, um, it is formed because of the presence of electric charges. And within this field, we have this force that is called electric force, which influences the activity of those electric charges. So it also follows the idea as previously mentioned by Ms. Lim that unlike charges attract while like charges repel. All right, that makes sense. Electric fields, we electric fields has these characteristics, and electric charge is a property of matter that causes two objects to attract or repel depending on their charges. So we mentioned that an electric field is a region of space around an electrically charged particles or an object in which an electric charge would feel force. Mention na Santana. An electric field is a vector quantity and can be visualized as arrows going toward or away from charges. The lines are defined as pointing radially outward away from a positive charge or radially inward toward a negative charge. So electric field is a type of vector quantity, and as we recall, vector quantity is a quantity that associates itself with a magnitude and a direction. So kanang arrow niya, ang gitakton ang length of arrow that indicates the distance covered or mo na siyang magnitude, then the point of the arrow indicates the direction. And this phenomenon is the result of property of matter called electric charge. Electric charge produces electric fields, right? Regions of space around electrically charged particles or objects in which other electrically charged particles or objects would feel force. So, nakacover na siya. Summarize. Next, please. Next slide. So this is how electric field looks like in a planetary model. So it, as you can see, it is very similar with magnetic field. Only that electric field is present in electric charges, while magnetic field is present in magnets. Okay, next slide please. Electric charge, an electric charge which can be either positive or negative is a property of matter that causes two objects to attract or repel. If the objects are oppositely charged, for instance, positive or negative, they will attract. If they are similarly charged, positive or negative to negative, they will repel. So the unit of electric charge is the coulomb. It is symbol niya, by the way, is C, and which is defined as the amount of electricity that is conveyed by an electrical current of 1 ampere in 1 second. Atoms, which are the basic units of matter, and are made of three types of particles. These are called the by the way, subatomic particles. They are the electrons, neutrons, and protons. Electrons represent negative charge, neutrons represent uncharged, while protons represent positively charged. Many of which are electrically neutral and have a total net charge of 0. If there is an excess of either electrons or protons thus yielding a net charge that is not 0, the objects are considered charged. That makes sense. Next, one way to quantify electrical charge is by using the constant E, and it is valued in 1.602 times 10 to the power of negative 9 coulombs. And they vary depending sa sign. If we say if We say electron na siya negative sign, while proton na siya positive na sign. And next, the electric field formula. An electric charge produces an electric field which is a region of space around an electrically charged particle or object in which an electric charge would feel force. So reiterate mo na ako ang katong definition niya. The electric fields exist at all points in space and can be inserted by bringing another charge into the electric field. However, the electric field can be approximated as zero for practical purposes if the charges are far enough from each other. Electric fields are a vector quantity and can be visualized as arrows going toward away from the truth. The lines are defined as pointing radially outward away from a positive charge or radially inward toward a negative charge. So kani siya ma-view ra nila to sa katong graph nga that we showed earlier. Next slide please. The magnitude of electric field is given by the formula E equals F over Q, where E is the strength of the electric field, or it is the intensity, while F is the electric force and Q is the discharge that is being used to fill the electric field. And example, electric field of 2-point charges. For 2-point charges, F is given by the Coulomb's law above. Thus, F equals, if kanin siya, may tabo na ni siya if there are 2-point charges or kaning Q niya. So thus F equals to K, which is constant, times Q1, Q2 over R squared, where Q2 is defined as discharge that is being used to fill the electric field. We then use the electric field formula to obtain E equals F over Q2, since Q2 has been defined as discharge. And after substituting for F, then we have this final formula, which is E equals to K times Q1 over R squared. That's it. And next, we have Ms. Amahan to discuss electrostatics.
So, good day, everyone. I will discuss the topic for electrostatistics. So, next slide, please. So, electrostatistics. It is the study or a branch of physics that deals with the phenomena and properties of stationary or slow-moving electric charges. Electrostatic phenomena arise from the forces that electric charges exert on each other and are described by the Coulomb's law. So, kanang based on in continuation with the Coulomb's law, electrostatic is merely the study of the electric charges that are at rest. The fundamental concept in electrostatic is electrical charge. We are all familiar with the fact that rubbing two materials together, for example, a rubber comb on copper. So another example is, as mentioned by the other reporters, are katong balloon in your hair, rubbed in your hair. So it can produce a static charge. This process is called charging by friction. Surprisingly, the exact physics of the process of charging by friction is poorly understood. However, it is known that the making and breaking of contact between the two materials transfers the charges. So in transferring charges, we need these two materials, a conductor and an insulator. A conductor is a material through which electric charges can easily flow. The examples are shown: the metals aqueous solution of salts, such as kaning naa diri sa example, the silvers, gold, copper, steel, and seawater. For the insulator, it is a material through which electric charges do not move easily, if at all. So examples are rubber, glass, oil, diamond, and dry wood. Insulators are the electric charges cannot move, cannot be transferable in this. So next slide, please. So In studying electric charges, we need the electroscope. As it is mentioned earlier, the use of the electroscope. So let me reiterate it. So electroscope is a simple device used to indicate the existence of charge. It can detect whether the object is producing a electric charge. As shown in Figure 1, the electroscope consists of a conducting rod and attached lightweight conducting leaves, commonly made of gold foil. Once the object touches the knob, the light charges repel and force the leaves apart. The electroscope will indicate the presence of charge but does not directly indicate whether the charge is positive or negative. So, um, the it is helpful for us to use the electroscope because it can detect whether the object is conducting the object is um, there are present electric charge on the object, but um, it cannot detect whether if it's a positive or negative charge. So in the figure 1, an, a large charge near a neutral electroscope can make the leaves move apart. The electroscope is made of conducting material, so the positive charges are attracted to the knob by the nearby negatively charged rod. So we all know, gibalik-balik sa ni, that um, like charges repel, but unlike charges attract. So positive and negative charges will attract to each other. The leaves are left with a negative charge and therefore deflect. When the negative rod is removed, the leaves will fall. Now, consider touching the electroscope knob with a finger while the charge rod is nearby. The electrons will be repulsed and flow out of the electroscope through the hand. If the hand is removed while the charge rod is still closed, the electroscope will retain a charge. This method of charging is called charging by induction. So next slide. As you can see on the figure 2, it shows charging an electroscope by induction. When an object is rubbed with a charged rod, the object shares the charge so that both have a charge of the same sign. In contrast, charging by induction gives us an object that the charge opposite that of the charge rod. Even though the charges are not free to travel throughout the material, insulators can be charged by induction. A large charge nearby, not touching, will induce an opposite charge on the surface of the insulator. As shown in Figure 3, um, the negative and the positive charges of the molecules are displaced slightly. This realignment of charges in the insulator produces an effective induced charge. So, in the Figure 3, induced of surface charge and then insulator by a nearby charged object. So, next slide, please. In connection with the Coulomb's law, as I've said, that electrostatistics phenomena arises from the force that electric charges exert in each and described by the Coulomb's law. For for the Coulomb's law of electrostatistics, there are three. So the first law, it states that the charges of electricity repel each other, whereas unlike charges attract to each other. So the second law of electrostatistics states that the force exerted between the two small charged bodies is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. So the formula is the mathematical equation of the second law of electrostatistics. So the force is equals to the constant of also where Q1 and Q2 are the charges, R is the distance between them, and the K is the proportionality constant. So the SI unit of the charge is the coulomb. If the charge is in coulombs and the separation of meters, the following approximate value for K will give the force in newtons. K is equals to 9.0 times 10 to the power of 9 Newton times meter squared over coulombs squared. The direction of the electrostatic force depends upon the signs of the charge. So, as I've said on the first law, like charges repel and unlike charges attract. Coulomb's law can also be expressed in terms of another constant, permittivity, known as permittivity of free space. So the formula is absolute permittivity is equals to 1 over 4 pi k is equals to 8.85 times 10 to the power of negative 12 coulomb squared over Newton times meter squared. So next slide, please. When the permittivity constant is used, Coulomb's law will nahimo na siyang inani nga formula. So for force is equals to 1 over 4 pi absolute permittivity and charges Q1, Q2 over R squared. The most fundamental electric charge is the charge of one proton and one electron. This value is E is equals to 1.602 times 10 to the power of negative 9 coulombs. It takes about 6.24 times 10 to the power of 18 excess electrons to equal the charge of one coulomb. Thus, it is a very large static charge. For a system of charges, the forces between each set of charges must be found. Then, the net force on the given charge is the vector sum of these forces. The following problem will illustrate this procedure. So, next slide. Here is the example 1. Two equal and like charges are placed at the distance d is equals to 6 centimeter. They exert a force of 12 times 10 to the power of negative 3 Newton on each other. What is the magnitude of each charge? For the solution, the magnitude of force between two static charges separated by a distance d is given by Coulomb's equation as follows. So we will use the Coulomb's equation. Force is equals to the K Q1, Q2 over the distance. K is the Coulomb's constant and has the value of 8.99 times 10 to the power of 9 Newton times meter squared over coulomb squared, and let the magnitude of the charges be in its absolute value. Next is we will substitute the values in the equation. So we will substitute 12 times 10 of 10 to the power of negative 3 is equals to 8.99 times 10 to the power of 9 times the Q2 over 0.06 squared. So if you're wondering, nganong nahimo siyang 0.06 squared, because the given distance is in centimeters, so we will convert it into meters. So 0.06 squared. Q2 is equals to 48 times 10 to the power of 16, while the Q is equals to 6.9 times 10 to the power of negative 8C. So the magnitude of each charge is 6.9 times 10 to the power of negative 8 coulomb. Next. For the example 2, what is the net force and its direction at the charges of the vertices A and C of the right triangle ABC exert on the charge in vertex B? So vertex A has positive 7 microcoulomb, B has positive 2.0 microcoulomb, C has negative 2 microcoulomb. Next slide. For the solution, let force AB be the force of repulsion exerted by the charge at A on the charge at B, and force CB, um, force CB be the force exerted by the charge at point C on the charge at point B. The diagram below shows the direction of these two forces. We first use Coulomb's law equation, which is the force equals to constant Q1, Q2 over R2 to find the magnitude of these two forces. So we will substitute each value in Pythagorean theorem to find the magnitude of the resultant force. F is equals to force AB plus force CB, a vector sum. Therefore, for the for the we will get the theta arctan k times 10 to the power of negative 8 over 0.085 k to the times 10 to the power of negative 8 is equal to 48.0 degrees. So next slide, please. For the last example, a positive charge Q exerts a force of magnitude negative 0.20 N Newton on another charge negative 2Q. Find the magnitude of each charge if the distance separating them is equal to 50 centimeters. For the solution, the force that Q exerts on 2Q is given by Coulomb's law. The force is equals to K times Q times negative 2Q over the distance, which is the 0.5 meter. Force is equals to negative 20 N. Negative minus 0.2 is equals to negative 2 Q2 K over 0.5 squared. So the Q2 is equals to negative 0.2 times 0.5 squared over 2K. For um for the so we will get the Q is equals to 1.66 times 10 to the power of negative 6 coulomb. Then negative 2Q is equals to negative 3.23 times 10 to the power of 6 coulomb. Next. So that's all. Thank you.
So, good morning, everyone. We are the fifth group, and we will be reporting about electricity, voltage, current, resistance, and Ohm's law. Next page, please. Our group mates are Maria Leon Chu, Jezreel Taneo, Yancy Sarmiento, and Fratchilin Secretary. Voltage. I will be the one who will report the voltage. I am Maria Leon Chu. Okay, voltage is the difference in charge between 2 points. We measure the potential difference or voltage in V or volts. It was named after the Italian physicist Alessandro Volta, who created the voltaic pile, the first battery to provide a steady current. Voltage and volts are different. Voltage is the pressure, while volts is the unit we measure pressure in. We can measure it using the voltmeter or a multimeter. Okay, wait a second. So explain. The required amount of energy to move the unit charge from one point to another is known as voltage. Voltage is the potential difference force between the 2 points in an electric field which causes current to flow in the electric circuit. In other words, voltage is the main cause and current is the effect. Next page, please. In describing the common analogy between current, voltage, and resistance, here is a water tank. The amount of water from the tank is represented as the current. Voltage is the water pressure and flow is the current. In here, the pressure at the end of the hose can represent voltage. The water in the tank represents the charge. The more water in the tank, the higher the charge. The more pressure is measured at the end of the hose. We can think of this tank as a battery, a place where we store a certain amount of energy and then release it. If we drain a tank at a certain amount, the pressure created at the end of the hose goes down. We can think of this as decreasing voltage, like when a flashlight gets dimmer as the battery runs down. There is also a decrease in the amount of water that will flow through the hose. Less pressure means less water flowing. Okay, next page, please. In here, we can see that there is a 1.5 volts to power a lamp. In here, kanang pakita na to na usa ra man ka battery ang iyahang gigamit, unya gamay pa jud ang volts, which means ang kanang lamp kay dim na siya, kanang gamay ra siya og siga, unya dali sa na siya makurot. The next page, please. In here, this is a parallel connection. There is kanang duha ka battery which is 1.5 but dili siya kanang sagol god, lahi-lahi iyang connection towards the light bulb. So ang kanan niya, ang lamp kay dim gihapon siya pero dugay siya mahurot kay since duha man ka battery ang gigamit para i-power siya. Next please. In here, ang duha ka battery kay gisagol na, which is nahimo na siyang series connection. I-measure na niya sa multimeter kay na-add ang duha ka battery na 1.5 volts, nahimo na siyang 3 volts. So na-boost ang ihang connection, meaning more voltage kay more pressure. More pressure means more force, therefore the lamp is brighter. Since mas daghan man siya og kanang volts, mas hayag ang light bulb, pero dali sad siya mahurot gihapon. Okay, next please. To measure voltage, we have to connect the multimeter, the circuit in parallel across 2 points. So ang kaning end sa kaning kaning sa multimeter na ay red o black, i-connect na siya sa kanang end sa connection sa kanang end sa light bulb. In here, nakita nato na ang 1.5 na volts, nag-supply siya 1.5 sa light bulb. Next, please. So, kani, 1.5 man siya, no, ang volts. Nya, pag-measure sa kanang light bulb, 1.5 siya sa katong end sa first light bulb antod sa kaning second light bulb. Pero, kung i-measure na siya individually ang kaning usa ka light bulb sa end sa iyang usa ka light bulb, mahimo na siyang 0.75 since nagtunga raman ang duha ka light bulb sa 1.5 nga volts. Okay, next please. Voltage in parallel and series connection. So, ang volts in a parallel circuit, the same na siya all throughout the circuit. Ang sa series, kay diri siya nagkalahi. Ang voltage siya, each connection sa series, kay dapat equal siya sa kanang battery. So, in here, we can see nga, ang voltage niya starting kay 12 volts. Kunya, tinalan pa nato ipangitaon ang volts sa kaning first resistance o kaning second. Nya, wala man tay kanang current diri, wala man ang I. So, i-solve usa na ang I, kaning 6 plus 2 na resistance, unya equals 8. 12 volts divided by 8 resistance, so mahimo siyang 1.5 amperes na current. Unya, ang formula man sa volts kay E equals kanang current times resistance. So, equal na to, 1.5 times 6, mahimo na siyang 9 volts. Unya, 1.5 times 2 kay mahimong 3 volts. So, muna i-add nimo sa kaning 9 volts o 3 volts kay 12 volts ang gigamit pag power sa kaning connection. Same siya sa katong battery nga 12 volts. Next, please. In Ohm's law, the formula for voltage will be E equals IR, where E's unit of measure is volts. It is read as voltage equals current times resistance. So, nganong gitawag mo na siya E, nganong dili man na siya volts. So, ang kuan ana niya kay karaan man na siya na name, iyang name sa una kay electromotive force. Nga mo na siya ang gigamit ay kanang tawag sa kanang pag-power good sa kanang kuan sa kanang electron nga na kana mo na siya ang energy na mag-supply sa cell, mo na siya gitawag na siya E, electromotive force, or same na gihapon na siya sa volts na gihapon. Okay, next please. So here is an example problem. Ang given nato ang resistance is 8 and we have a current of 5 amperes. What would be the volts? Next please. What is the voltage in the circuit? So we multiply the 5 nga current times 8 nga resistance, we will get 40 volts. Next please. How much voltage is required to make a 6 amperes of current flow throughout a 15 ohm resistor? So same gihapon, ang iyang formula kay E equals I times R, 6 amperes times 15 ohms equals 90 volts. Okay, the next presenter would be the Chilean Secretary.
Wait sa guys ha, kay napawang akong laptop. Wait sa ha, kay na-stop ang recording, kay nalubat ko niya ako kabantay nga. Napawang na siyo. Wait sa. Di na ko ka-record, so padayon na lang ko kay naka-record naman. So, I'm Fritcheline, by the way, Secretaria, if you don't know me. So, ako si Fritcheline, Secretaria. I'm going to discuss about the current. So, current is the rate at which charge flows past point on a circuit. The current in a circuit can be determined if the quantity of charge passing through a cross section of a wire in a time can be measured. So the current is simply the ratio of the quantity of charge and time. So next slide will be a video explaining what current is. Slide please, Yancy. Walay tingog yan. Paliw ko sa imong on, sa imong mic on. Thank you.
Current is the flow of electrons in a circuit. To use electricity, we need electrons to flow in the same direction around a circuit. We usually use copper cables to form the circuit because the atoms that make copper have a loosely bound electron in their outermost or valence shell, which is free to move around inside the metal. This free electron is very easy to move, which is why copper is so popular. It's so easy to move that it will naturally just move to other copper atoms by itself, but this occurs randomly in any and all directions, which isn't useful for us. For us to make use of this, we need lots of electrons to flow in the same direction along the circuit. We can then place things like lamps in the way of these electrons so that they flow through it, and then they generate light and heat, etc. To do this, we need to force the electrons to move, and we can do that by applying a voltage. Voltage is the pushing force. It's like pressure in a water pipe. The more pressure we have, the more water can flow. The more voltage we have, the more electrons can flow.
So next is, next slide, please. So the next slide is the nature of charge. So before ana kay kanang nakoy gamay lang nga detail. So according to Ohm's law, the current is the ratio of the potential difference and the resistance. Thus, the current formula is given I versus V over R. So mo ang next nga slide. Okay. So the nature of the charge flow, charge carriers in the wires of electric circuits are electrons. So these electrons are simply supplied by the atoms of copper or whatever material the wire is made of. So within metal wire, once the switch is turned on, the circuit is closed. The difference is established across the two ends of the internal circuit, and the electric field signal travels at the speed of light to all mobile electrons within the circuit, ordering them to begin marching. Then, as the signal is received, the electrons begin moving along a zigzag path in their usual direction. Thus, the flip of the switch causes an immediate response throughout every part of the circuit, setting charge carriers everywhere in motion in the same net direction, while the actual motion of charge carriers occurs with a slow speed. The signal that informs them to start moving travels at a fraction of the speed of light. So kanang nasad ko ay kanang lain na example of that kanang nature of charge flow. So the electrons that light the bulb in a flashlight do not have the first travel from the switch through 10 centimeter of wire to the filament. Then rather the electrons that light the bulb immediately after the switch is turned to on are the electrons that are present in the filament itself. So as the switch is flipped, all mobile electrons everywhere begin marching. So, asa naman ko? Wait, So, and it is mobile electrons presented in a filament who's are responsible for the lighting the bulb. As those when a faucet is turned on, it is the water in the faucet that emerges from the spigot. One does not have to wait noticeable time for water from the entry point to your home to travel through the pipes to the spigot. So the pipes are not already filled with water, and water everywhere within the water circuit is set in motion at the same time. So next will be the standard metric unit used to express that quantity is introduced as well. So the standard metric unit for current is ampere. So ampere is often shortened to amp and is abbreviated by unit symbol A. So current of 1 ampere means that there is a 1 Columbus of charge passing through a cross section of a wire every 1 second. So 1 ampere is equals to 1 coulomb or 1 second. So next please. So mo ni akong gisulti ganina. So according to Ohm's law, the current is the ratio of the potential difference and the resistance. Thus, the current formula is given by I is equals to V over R, or current equals voltage over resistance in amperes. So next will be our kanang examples or kanang practice to solve the coin. So using this problem in an electric circuit, the potential difference and resistance are given as 20 volts and 4 ohms respectively. Using the current formula, find the current flowing in the circuit. So I need someone to answer this. Sayo na ram jud kayo. Kuan ram to I versus I equals V over R. Kung maka-answer mo, okay Rasad. Kung dili, okay Rasad. Just raise your hand or pwede na mo lakos. Okay, Melvin.
5 amps answer.
5 amps. Sige, next, Yancy. Let's see kung sakto ang answer ni Melvin. Yancy, next slide, please. So, to find the current I flowing in the circuit, given V is equals to 20 volts, then R is equals to 4. Then using the current formula, I equals V over R. So, I is equals to 20 over 4. So, ang answer is I is equals to 5. So, the current flowing in the circuit is 5 amperes. So, sakto si Melvin. Thank you, Melvin. So, next is last example. So, the total current flowing in an electric circuit is 50 amp, whereas the resistance of the wires is 14 ohm. Dili ni siya 140, 14 rin. So, using the current formula, find the potential difference. So, potential difference na siya. Kung may someone yung maka-answer sa question, I'll record it. Just raise your hand or kanang answer lang directly. So, no one. So, next slide na lang Yancy. So, to find the potential difference, ganina kay, kuan man to sa I over, kanang I is equals to V over R. So, kani siya kay, ang gihatag naman is ampere ug ohm. So, ang mahitabo ni ang I kay butangan siya og 50 equals V over 14. Kay ang 14 may resistance, then wala man gatagang ampere. Ay, ampere ang volts, then ang volts. So, ang mahitabo ani si 15 na siya sa pika. So, imo siya i-transfer para mo siyang 50 times 14. So, ang volts is equals to 700. So, that's all. Thank you. And next will be just a real Taneo discussing the resistance.
Good morning, everyone. I am Joshua May R. Taneo, and I'm going to report about resistance. So, what is resistance? Next slide.
Excuse me, is Giselle talking? Are you presenting now? Or walay sound ng atong kuan? Sige. Okay.
Di siya madungog.
So wait for a moment kay nawalang signal ni Giselle.
Okay. Next slide ba ulit?
Excuse me, is the presenter still talking?
Di siya madungog, miss.
Then, so, naay laing presenter nga ni Kuan, ni Puli. If she cannot be heard, so what's the purpose? Basig na mute na ang iyang Kuan, iyang speaker.
Nikatingog siya ganina, miss, pero inigsugod sa report kay mawa siya. Nakakuan siya, nakaingon pa siya nga next slide.
So, saan man ni nato ron?
Mo-proceed na lang si Yancy, miss.
Okay. Who was that presenter? Itong wala siya Kuan audio.
Jezreel Taneo, miss.
Now, who will be the next one to present? Please.
Ako, miss.
What's your name?
So, I am Yancy Dominic S. Sarmiento, and I am going to report Ohm's law. So, Ohm's law is a formula used to calculate the relationship between voltage, current, and resistance in an electrical circuit. So, Ohm's law is a very simple and useful tool for analyzing electric currents. It is used so often in the study of electricity and electronics. So, kaning makita niyo diri nga triangle, this is called Ohm's law triangle technique. So, mao gyapon ni siya ang formula sa kanang Ohm's law. Like this kanang if nangita mo sa resistance, so manion ra ninyo i-crush out ang R, tapos makita na dayon ang formula E over I, and then same ra gihapon sa if nangita mo sa current is i-crush out ra gihapon ninyo ang current which is I, and E over R makita ra ang formula. And diri sa kuan gyapon sa voltage is i-crush out lagi hapon which is voltage equals current times resistance. So next. So name ang nag-create based sa kanang Ohm's law was si George Simon Ohm or George Ohm. So quantity, voltage. So ang Ohm's law symbol sa voltage is E, and which is one electromotive force ang old term niya. So current and the current is Ohm's law symbol niya is I, which is intensity, and resistance is R. So mao ni siya ang kanang formula sa kanang Ohm's law. R equals E over I equals E over R, and E equals I times R. So this is my example is example 1, and voltage and resistance are known. So what is the current in the circuit? So ingani na siya pag solve. So ang formula ani kay kanang intensity equals kanang current equals voltage over R. So i-divide 12V over 6 ohms. So ang answer is 2A kay 1 i-divide na siya. And this is the next example. Voltage and current are known. So ang pangitao na to diri kay kanang R, which is resistance. So ang current is 6 ampere and ang voltage is 24 volts. So what is the resistance created by the lamp? So ang atong pangitaon ana kay resistance. So ang formula ana is resistance equals voltage over current. So mo ni siya 24V over 6 amperes. So divide gyapon na siya. So ang answer is 4 ohms. So kani siya ang pagitaon na sad nato ani kay kanang voltage. So current and resistance are known. So what is the voltage? So ang resistance ay 8 ampere ay 8 ohms and ang current is 5 ampere. So next, what is the voltage in the circuit? So ang formula na tong gamiton ani kay kanang voltage. So E equals current times resistance. So kani 5 ampere times 8 ohm. So i-times siya ng duha and the answer is 40 volts. So that's all. Thank you.
Okay, excuse me, do we still have another presenter? Are we through? Group 6? Are we through, members of group 6? Excuse me?
Group 5 ni. 5 ni.
Ha?
Wala pa, miss.
Group 5 ni.
Group 5 pa mo. So, pila man ka both members ang group 5 nga naka-present today? May I know, all of you? Sige, ang katong first nga ni-present, ako lang i-check.
Si Kuan, Ma'am Mariela Leanne Chu, and Pritchelin Secretaria. And
Wait
then
ka ha. Unahon sa nato ang apelyido ha. One at a time, please. So, who was the first presenter sa group 5?
Si Chu, Miss
Apelyido is?
Chu.
Chu?
D-I-U. Yes, Miss.
D-I?
Miss T.
T-I, si Chu Mariel Yegan. Mao ni siya first nga ni-present sa group 5?
Yes, miss.
Yes, Miss.
Okay, next, ang second presenter is?
Pritchelin Secretaria, Miss.
Secretaria. Okay, next. So, ikaduha na ni. Then, who else?
Si Kuan, Miss, si Jezreel May Tanillo, kay wala siya nakakuan, kay wala di siya madungog, Miss.
Atong wala na tiwas, no? Okay, naputol lang kay wala na ang iyang audio, wala gyud sound. Okay, mo na siya third. Ang ika-fourth was si
Kuan,
Sarmiento.
Miss Sarmiento yan si Dominic. Yes, Miss.
Then, ang ika-fifth,
Maura na tanan, Miss.
okay, so kanira sila. So, nahuman na ang presentation sa group 5, right?
Yes, Miss.
Yes, miss.
And then, group 6 na pod ang mo present. But it seems na 30 pila na lang ka minutes, 40 minutes na lang ang group 6. And then, how many members are there in group 6? How many members do we have in group 6? Hurry up. Group 6? How many members are there in your group?
5 mi ka
5 mo kabuok. Yeah, do you think kaning 5 kabuok mahimo pa ni? karon?
Excuse me, Miss.
Yes.
Ang nag-report karon Miss kay 4 ug 5 ang nakabutang sa amo Miss nga mo report ni ka 18 pa.
4 and 5 karon. How about group 1 and group 2? Naka-report na no niya. Group 3 and group 4. So, why? Nga nung wala man siya na
Ano Miss
pares?
kami to na section katong ang
Yes.
Atong ang una miss ba kay usaray atong first day sa reporting kay usa pa ang naka-report katong group 1 then ang second kay katong 2 and 3.
Group
That's
2
why
and
karon
3.
ang yes miss niya. That's why karon kay 4 and 5 then next week is katong 6 and 7.
So ang presenter sa group 4 humana. Ganina.
Yes miss. Ganina miss.
May I know their names? Isugod lang sa first presenter sa group 4. Okay, group 4.
Lim.
Apelyido